Today's daily Go problem of the day is count number of maximum bitwise OR subsets, number 2044. For this problem, we're given an integer array called nums. We want to find the maximum possible bitwise OR of a subset of nums and return the number of different non-empty subsets with the maximum bitwise OR. So, what does this mean? This means, for example, if we have the array 2, 1, 3, 2, we can make a subarray or a subset of 2, 1. That's a valid subset. We can make a subset of 2, 1, 3. That's a valid subset. We can make a subset of 1, 3, 2. Or what we could do is we could include 2, 1, not include 3, and include 2. This is also a valid subset. Now, what does it mean to do a bitwise OR? So what is a bitwise OR operation? So for a bitwise OR operation, we're going to take two numbers. For example, we have the number 5. Its bitwise OR representation is 101. Sorry, its bitwise representation is 101. And then we could take the number 2, whose bitwise representation with 3 characters will be 0, 1, 0. So these are 5 in bit and 2 in bitwise representation, or 0 and 1. Now, for a bitwise OR operation, we are going to look at each index of the bits and compare it to the other. So we're going to go straight down the line from right to left. We're going to look at 1 and compare it to 0. It's similar to a Boolean expression. So if we have 1 true and 1 false, and it's true or false, we're going to say true. If we have 2 falses, it's going to be false. And if we have 2 trues, it's going to be true. So in this case, we could look at 1 as a true and 0 as a false. So 1 or 0, well, we're going to keep the true. So 1, and then we have 0 or 1, we're going to keep the 1. 1 or 0, we're going to keep the 1. So this is the bitwise OR of 5 and 2. So if we OR 5 and 2, we'll get 1, 1, 1, which is basically equal to 7. So this would be equal to 7. And now it's not equal to 5 plus 2. In this case, it just happens to be 5 plus 2, just how the bits align. But typically, that's not how the operation works, right? For example, if we have 3 and 2, 3 would be 1, 0. Sorry. 3 would be 0, 1, 1, and 2 would be 0, 1, 0. So if we do the bitwise OR operation for this, we have 1 or 0, 1, 1 or 1, 1, 0, 0, 0. So it ends up being equal to 3 still. Simply how the bitwise OR operation works out. So for this problem, we are going to simply calculate the maximum OR first. This is because the maximum OR of the entire array would be the maximum possible bitwise OR of the subsets as well. So the first thing we'll do in this problem is calculate the maximum OR. So our int max OR will start at 0, and we'll simply take each integer num in our nums array, and we will max OR, and then we'll OR equals num. And that's it. So that's how you calculate the OR of a value. Then we're going to call to a helper function, and that's going to help us solve the rest. We're going to have 2 possible case scenarios. We'll either include a value or we will not include a value. This will be a recursive function, and so we will simply go through each possible subset by either including or not including a number. So we could call to our helper, and whatever our helper returns is going to be the result. So we could return our helper, and we're going to pass it a couple of values. First is our nums array. Then we're going to pass it our max OR, because that's what we want to compare each subset to. And then we'll pass it 2 initial values of 0, which represent our current index and our current OR value. So let's go ahead and define this helper function. So we're going to have a private. It's going to return an integer helper as an integer array called nums. We have our max value, and then we have our int index and our int current OR. So this is our max OR, this is our current OR. We can update that. So there's first going to be a base case, and obviously if our index is at the end of the array, we are going to want to break out of our recursive function. So we'll check if our index is ever equal to nums.length. Then we're going to return, and then we're going to have to do a little bit of calculation here. So we're going to check, is our current OR equal to our max OR? If it is, we will return 1. Otherwise, we will return 0. 1 being valid, 0 being not valid. So that's it for our base case. Otherwise, we are going to check what if we don't include this current index, and what if we do include this current index. So we're going to say int without is going to call our helper function again, and we're going to pass the same thing. So we're going to pass nums, we're going to pass our max OR, and then we're going to pass index plus 1. So we're going to increment through our array, and then we're going to pass current. So it may look like we're not doing anything here. We're just calling the helper function again and incrementing index, which is exactly what we're doing. So without is saying, okay, what if we just do the helper function with the next index and not include our current index? So anyways, this is our without case. And then we can move on to our with case. So our int with is going to be basically the same thing. We're going to call to our helper again. We're going to pass nums. We're going to pass our max OR. We're going to pass our index plus 1. However, we're going to change one thing, and we're going to do that by taking our current OR value, and we're going to OR it, with the current nums of index. That's the only difference. So this is where our OR operation takes place, and we will update the current OR value to be current OR or the nums of index, effectively completing that with section. So we're saying if we include the current index in our subset, this is the current OR value. And then we'll recursively call until we reach the end of the array. Then our solution will be whatever with and without return. So we'll return with plus without. Because without will find its own subsets, with will find its own subsets, and whatever their total is what we want to return. So if we run this, passes our test cases, and if we submit it, passes all solutions. So thank you, and follow for more daily Leetcode solutions.